to just to set up the lathe, the threading part. When I bought the Baxter, they didn't make a stop. We came up with this idea ourselves. We need a stop, and we need this, and I'll show you why we need that a little later. This is the Baxter system. This is a highly refined machined piece of equipment. Let's see here. There we go. I don't know what you can you see this? This adjustment, for example, is calibrated in thousandths. I can actually calibrate my thread cutting by 1/1000th of an inch. I can advance, 5/1000ths if I want. I can precisely control what I do there. And this, of course, is a shaft that's got 16 threads per inch. It's going to control coming into the cutter. And as I mentioned earlier, the people that make this machine, they make it in that whole range of threads. If you want a different thread, you take this top block off and you put a different block on that's got 10 threads per inch or 20 threads per inch, whatever you want. That block comes on and off. And then also there's a spacer block. When I converted from a 10-inch swing to a 12-inch swing, I had to take this plate out and put a block in here that added an inch. So I can basically run this on either lathe. And you can buy these; they'll be custom made, to the riser, because this has to be on center for everything to work right. So that's one option. Another neat thing is the piece that you're going to turn. This is a 1 1/4 8 threaded piece, but this is a 1/8 and this is a M33. So when I'm in my shop, I'm preparing the piece I'm going to thread with an M33 on here, and this is on here instead of this. I put this on because I knew I was going to be here, and I knew this was 1 1/4, so that's why I'm here. So that's another nice aspect of this. Then you need a cutter. The cutter is a collet. Goes in the standard Morse taper that's on virtually all of your lathes, and then the cutter itself is actually from the machining world. Okay, and this is what the cutter looks like. I don't know if you can see that. These are a little cutter, a little machine cutter. Now this is not the way the cutter came to us. We modified it. Here's what the cutter looks like initially. I don't know if you'll be able to see this. But what we've done with this cutter is we've ground off the face. We ground off the face. Well, why would we do that? Well, we do that because we want to be able to cut the thread as close as we can to the shoulder. And by grinding that off, I can come closer. This one doesn't have that on there, so I can't get as close with this cutter. Now, the interesting thing is, we put this cutter, we put this into our, it just slips in there, goes in here. We put that cutter in about, let's see, 15 years, probably 15 years ago. And my mentor, he thought, well, we better get a backup cutter, because somebody over there asked, well, how do you sharpen these cutters? So he said, well, we better get a backup cutter. So we ordered another one. Okay? This is still in the original wrapping. I have been cutting threads for 15 years with that cutter, and I've never touched it with anything. And I've probably cut, conservatively, maybe 1,000 threads, maybe more. I've cut a lot. I've cut a lot of threads. So it's kind of interesting. I still carry this around because I have it. But But it's really, and I'm kind of want, I kind of feel like I ought to change it because, how can this still be good after cutting 1,000 threads or so? But it still seems to cut very nice threads. So I'm saving this for the next 15 years. All right, so when the holder is a collet and you push this in here, you can't just say that's good enough because you got to pull it in with a drawbar. So you make a drawbar, and this is the original drawbar with the lathe, and so this just goes in there. This collet has a threaded end on there, so I just catch that in there. Get this tightened in here. Tighten it down. Now I'm good to go. So I've got a spinning cutter. I'm set up at about three. I'm going to run about 1,800 to cut. The faster you run, the better it is. I could run faster than this, but one of the reasons I don't is because if this is a little off center, it starts vibrating. I don't know if you notice it, but I wrapped some tape around there that nicely centers it, so I could probably run it faster, but 1,800 cuts very nicely. So this is the setup. So every time you set up the thread, you basically have to get a lathe and set it up like this. Donna, this is one threader, but Donna brought a different kind of threader. Do you want to just show that and show maybe the big thing might be the price difference? I'm not sure what that is, but you would show that on here, right? You should rather show it on there. So we'll just. Well, you don't need, I don't think you need that. I think it's probably more just this. I just wanted, I wanted Donna to show us that there are other options for machine threading. There's not just one. So.
Okay, good. This is the cutter on this one, just to show you, and I have it in a holder that I bought from them. It's probably about the same thing. This one you set up with the tailstock, with the point will go in here, and that will center it.
No.
Yeah, it would center it.
They would have to drop it. I don't think it can.
It probably won't, but that's the way I would center it, with in the dimple in here with the tailstock. And then once I turn I won't use that, but I do the same way. I turn the lid first, and once it's turned, then I would put it in my chuck, or it would take the chuck off of there and thread it onto here.
See, she's doing like Chris did. She's making the lid the female thread, which is the opposite of what I do. Were you hanging around with Chris? Is that why you do it that way, or was Chris hanging around with you?
Yes, it's a Simon Hope wood turning threading jig. Simon Hope, and he's from England. That's where I bought it, and I bought it a few years ago. Since then, I found out that he no longer ships to America, but you can get it different places. But the one that I know for sure is Black Forest Wood Company, and that's in Calgary, Canada. And you can reach them, and then they'll give you price on shipping and insurance. Simon Hope said that the insurance to ship it was just too cost prohibitive. He couldn't do it anymore. But I can get parts if I need to from Black Forest. But after I would turn it this way, then it would be on here. And I'm sure that Roger will explain that you match it up to this and do kind of a kiss test. And then this is not, you don't have to measure with this. It's in clicks. So for the 16 tooth, after you once do the kiss test and get it matched up close, then you can turn it in 4 clicks. Tighten it down. Well, it's not on there. turn it in 4 clicks. And then when you bring it back out, usually I put a little CA glue on there or something to stiffen up the fibers, because you can use it on anything. Like he said, any domestic wood. You can turn, I've turned cedar and it turned out pretty well. And then, once I run it in and do the KISS test and I go back into that recess that he talked about, then I can bring this collar up. It's a stop collar, it has a grub screw in there, and it will stop at the same place every time. So I would back it back out, and I would turn the speed up. He says turn it as fast as your lathe will go. Well, I think mine goes about 3,500, but 3,000 scares me to death, so that's where I put it, usually about 3,000 RPM. And then I just turn it in, and it will go to, okay, oh, where do we go? And I can turn it as this is going 3,000, and I won't go past that stop. When it gets to that stop, I know I'm into that recess, and then I can back it back out. And I will, if I need to, put more CA glue on it or whatever. Then I will turn it in 1 more click and do it again. And that should be satisfactory. That should be a good thread. Then when I do the bottom of the box, and it goes on here, do it the same way exactly. Put the recess, go to the recess, put in your lock collar, and to measure, take your digital calipers, measure the inside of these threads, zero out your caliper, turn it larger by 1.1 millimeter. And then when you put it back on, those should match up. You've got it on here, you've got your lid made, you're working on the bottom. You want to know if it works or not. You can lift this up, try the lid on the bottom, and if it works, great, and it'll go back in exactly the same place. And if it doesn't, and I've had to just take a little bit of sandpaper and kind of sand off, hold it, run the sandpaper around, knock it off a little bit, and then go in maybe 1 more click, and hopefully that will do it. So it's pretty simple to use, but this I think is this is the main reason I picked this one, because I don't have to take anything off to try it. I can try it right on the lathe. Any questions?
So when it goes bad, how do you fix it?
When it goes bad,
Your thread didn't come out like you want, how do you fix it?
I haven't had that happen.
Just say, that is the answer. That is the answer. Literally.
The only thing is, you can make this the wrong size. You maybe, instead of 1.1, you go 1.15 or whatever. Then they are a little too big. So then you just run your sandpaper around the threads, bring it back out, and do 1 more click. And if it's still a little too big, same thing, a little more sandpaper if you got it too big, and then just 1 more click.
So then if your top, if it's 10 inch, you can always cut that down, but you can't make the female threads any smaller.
Exactly, except one time I did actually put it back on the lathe, lined it up, and returned those threads. I was able to do that, but that's not something I want to do.
I'll get into that, but her comment about of the hundreds and hundreds of threads that I've done, I've never gone back except one time to do it again. And when I went back to do it again, I redid the closure, because what happened is the wood must have not been totally dry, and when I turned it and threaded it, the thread was too loose, so it wouldn't catch. And so I actually said, I knew what I did wrong. I took a block of wood, and it wasn't dry completely, and it shrunk. And you shrink a few thousandths, and the next thing you know, you're slipping. And so I did that. It happened again, twice. And the second time, I thought, well, why in the hell am I going to make a whole new closure for this damn thing? And so I took some electric tape, which stretches. You take electric tape and you run it once around the thread. You pull it hard, and you pull it right into the thread, and by God, the thread was perfect again. And it's all sealed inside the urn. When you're done, you don't see it. So I thought it's kind of chinchy, but I've got one like that somewhere that's like that. So that's a possibility.
Yeah. But this hinge, I really think is great, and then this stop collar. Because you can, as many times as you need to sand it off and redo it, put it back down, you're always going to stop where that's where you have the stop collar in the recess. Yes. I that's about what I paid for it, really. Now I don't, and that was straight from Simon Hope in England, but that was a few years ago.
$425 plus shipping.
Yeah, that's what Mark said. Yeah, from where? From Black Forest? Oh, okay. And is that insurance and everything?
Okay.
Okay, probably.
Now we got to deal with England. You weren't paying attention. Yeah, we can shut this one off, I think.
Could you do the main piece first?
Yeah, you could. Sure. And like he said,
You shut that off.
put a different top on it or whatever.
Yeah, and you need to get rid of that. I'll take this for you. Okay. All right. So when I thread with the Baxter, a lot of what she was telling you about in terms of adjusting and checking and all that, I'm going to show you how I do it on the Baxter. But it's kind of the same thing. It's the same reasons. You know, you cut the thread and you want to make sure that the mate fits and that it fits properly. So the process here, and I brought, I kind of have a choice here. I brought a piece of holly, and by the way, this is exotic holly. It came all the way from Louisville. So this is not Iowa grown. Black walnut from here, or a piece of black walnut with a holly finial. So what would you like to see? It's black and white, black and white. Holly bowl, all right. That's bigger. I'd rather do that one anyway. So when you're going to turn a hollow form, and I turn all green, and I know a lot of you guys don't turn green, but if you don't now, you should do it. You should start doing it. So I take the holly, I take whatever I'm going to turn, and I rough it out. And I put it away. I hollow it out. You know, I cut a hole in it to hollow it, and I make a shape, you know, that I want to have. And I do that, and I put it away and let it dry. And in this case, I actually roughed this out in June of 2024. So normally I would not be turning this today. I'd say not dry enough. I don't trust that it's dry enough. But the reason I am turning it today is because when I rough turned this, I put the whole thing in alcohol. And it sat in alcohol for 2 weeks. Then I pulled it out. So this was probably dry 3 months after I roughed it. So I know it's damn well it's dry now. But I don't normally do that, and the reason I did it with holly is because holly tends to go gray. It just tends to color. And I wanted to try to freeze it, and I thought maybe I could do it with alcohol. And kill everything. If it's organic that's doing this, I can kill it. So that's what I did. Now, it's still not ready to thread. So today, to prepare for this meeting, I took this piece about a week ago, and I returned the tenon, and returned the whole piece. Took it all back to centricity. Now, and then I let it sit again for another week. Now it's ready to thread. Now, why did I do that? Well, every time you turn wood, especially if you're up in the crown of the tree, that wood is under tension and it's going to move. And it's not because it's drying. You know, that movement was taken care of by the drying. But every time you cut wood off, tension is released and it can tend to move some more. And so if I'm going to take a big piece, even a size this size, and I'm going to thread it, I don't want it moving anymore. I want it done. So that's why I do the multiple turning and put the time in there. So now when I bring it here, it's all trued up, but it's still not good enough. So I'm going to put it back in the lathe. I'm going to lock it down. And I'm going to look at it, and as far as the naked eye can see, it's okay. Look at this. Nope. So I'm going to put it back in here. And, when you thread things, whether it's a little box, a little hollow form of any sort, you want everything dead on center. You don't want the thing wobbling off to the side. You don't want the top to come in a little skewed. You want it dead center. You want the thread cut dead center. You want the female cut dead center. You want the male thread cut dead center. You want everything to line up dead center. And when I first started doing this, once in a while I'd get it perfect, but once in a while it would not be. And so eventually I sorted out what was going on. Was the wood moving on me? I can't take this out of the chuck and re-chuck it and expect it to be dead center. There's no reason why it will be dead center. It probably won't be. So I can't. So now when I chuck this up and true this up, I cannot take it out of this chuck. If I'm daydreaming and instead of taking the chuck loose, I loosen it up, I got to do it again. I just have to cut it again. But it's not a disaster because this is my main piece. If I have to do this again, it just makes the opening a little bigger. It's easier to get the cremains in there. So it doesn't hurt anything. So I can do that. So to start with, I will true this up. And that means facing this off. And when I face that off, I want it to be dead flat or a little concave. I definitely don't want it tipping the other way. Because on the closure, and if you look, I want all those closures to come down tight. The only one that doesn't is that damn thing with the Corian inserts in. But all these other ones, they come down nice and flush, tight and straight. So I want to make sure that that's straight and a little concave. So I'll just do that. Well, I was hoping it'd get caught, for a little excitement. That was is that okay? I was already thinking about that, Chris, and I thought if it does get caught, I should be strong enough to rip it off without tearing my face apart. But maybe it won't. I don't know. That's an interesting question, Will. Some people would probably tell you shouldn't do that. You should, if you have cross grain here, you should have cross grain on the closure. Most of my closures are end grain, almost all of them. And why do I do that? Well, if I'm going to do this and make a delicate finial, I can't do that out of cross grain. Do that out of cross grain, you tap this, it's broke. It's got to be end grain. And by the way, these are all one piece. This is not a Cindy draws a teardrop glued into the base. It's all one piece. So this has to be end grain. This is cross grain. This, who the hell knows? That's end grain. That's cross grain. Cross grain, cross grain. What I found, Will, is it doesn't matter. It just doesn't. No, the smaller you are, the less it matters. The bigger you are, the worse you get. Now, it does raise an important point. When I first started doing this, the one mistake that I made was I'd make the threads too tight. And if you make the thread, so it just, like Chris was creeping up on it, if you just creep up on it and you quit, you're way too tight. Way too tight. And then you close up the box and you set it on a shelf and you come up in July and decide to look at it and look inside of it, you can't get it open. You're screwed. So the message on threading is better to be loose than tight. Absolutely. Better to be loose, a little loose than tight. Because if you think about it, all the thread has to do is catch. It doesn't have to hold, 100 psi G. Doesn't have to hold that. These cremains, they don't create any, they just have to not leak, right? So a loose thread closing down tightly on the surface is all you need to seal it off. Don't go for any more, you're going to be in trouble. So when you cut your threads, cut them loose. So we'll just see here. How do you make this thing stay? You got some duct tape? Yeah. I didn't plan for that move. So this is very, very slightly concave. That's all I want. Thanks. So if I was in my shop, I would probably actually retrue this and probably finish it, sand it, finish it, so I don't have to touch this anymore. But I'm not going to do that today. But it's actually probably good enough. So the next thing is I've got to recheck this, and let's see here. Can you see that? This is a scraper. It's a regular scraper. You can see it's kind of angled off on the one side, and then there's a end. So these two surfaces form around a 90-degree angle, about that. Not important. You may wonder, why the hell did I angle this like that? I don't know. I did this so long ago. This was actually the first class I took, was down here in Des Moines, and we've got these Benjamin Bests. Remember back there? Remember all these Benjamin Bests? Here's one of them. And so I use this to set up for threading. And so I'll come in here and I will make sure that this is true, running true. So I've got to line this angle up here so it's parallel with the lathe, because we're not cutting pipe threads, we're cutting parallel machine threads. So you'd say, well, why the hell didn't you just make this straight? Then I could just line up the whole tool, but I didn't do that. Okay, and now, so I know that I've got a, when I first started doing this, I was so anal about this that I'd take a straight edge and put it on there and press it on there and make sure that it's parallel with the ways. I don't do that anymore. I can sight this parallel very well. And, I might sit on my lathe and do it, but I can do that. And you could, if I was doing it again, I would keep it straight on the line of the scraper. That way I could line the whole scraper up with the ways instead of lining up, 5/8 of an inch. So I'm lining up 5/8. I could be lining up, 6 inches. And if I did it again, that's how I do it. But I can make this work. I don't ever screw that up, ever. Now I'm going to do something else. I'm going to cut a groove in. Now, why do you think I did that? See, and Chris didn't do that. Well, why do you think I did that? Okay, now, when I thread this, I don't have to worry about a stop, right? I can thread right all the way through. I don't have to have any gap back there for a stop. I don't need any. I don't have to have this groove in the front either. I could thread right from the face all the way in. I could do it either way. So why do I do that? Well, I do it because I can. And I have a reason for why I want to do it. When I thread something, this thread is going to run all the way to the end. And I don't cut a gap in the back here either. None. So I can't thread all the way up here, but if I have that little groove in the front, I don't have to. Because where it's not threaded here, that fits into that groove. Now I do it this way because I can, but I also do it because when I go to put this in here, if this is flat, threaded all the way to the front, and this is threaded all the way to the front, I'm fishing around here and can easily get it cross grain. If I have that little groove in there, that just sits in there. Whoop, done. You see that? Very simple, but it makes it really easy if you're opening and closing it. No cross threading, no fiddling around. You drop it into the groove and you're good to go. So, that's why the groove is there. Now, the other thing I'm going to do is I'm going to chamfer the groove. And the reason I'm going to do that is because if I don't, I'll have a sharp edge on the thread and it'll probably break. So I'm just going to come in here at a 45, and I'm just going to put a little chamfer on it. That's just as the thread. See, Chris was taking a gouge and he was, or a skew, and he was rounding that off. I'm chamfering it, but for a little different reason, but in a sense, the same reason, to get the thread going nicely into the piece and not having a sharp edge that you're cutting over, which is probably going to break. Okay, so this piece now is ready to thread. Now, don't let me accidentally unloosen that piece, or I have to do it again. So, and I tell you, sometimes when I do threading, I usually do like half a dozen or 10 of these at a time, and you kind of go to sleep. And I've come up here, stuck this in, knowing I want to pull loosen up the chuck, but instead I loosen it up this way, and then this drops out. Now I got to start over and do all what I just did. I got to do it over. So see that I'm still awake. So now we're going to go over here. Well, this is all true. This thing is very true. I just screw this on here. And by the way, I'm doing big pieces on here, up to 11 inches or almost 11 and a half inches in diameter. Big pieces, so if you're not doing this right, you're going to get in trouble. But by doing it this way, I've been able to avoid that. Everything is running on center. And so now I'm going to take this up to here, put it in the vicinity of this. Now I'm going to turn this caliper that's calibrated in thousandths, and I'm going to move this over here to cut this female thread. This is probably the most tedious thing, is I got to do this. I'm not sure, Donna, if yours is easier to set that up. And then I'll move this ahead, and this rocks back and forth. See that? There's a little lanyap in there. And I don't want that, so I automatically pull it this to me and lock it down. I do that every time. So if I back off, check the thread, and bring it back, I'm going to bring it back and I'm going to pull it toward me. So the lanyap is taken care of because I'm always going to do it the same way. Now I'm going to take this little block here, slide that up and lock it down. Now I can back this up. Now Donna can just flip hers up, or she's got that little block that stops her. But I just use this, and this works, does all of that. So now I advance it, so the cutter's now in the vicinity of the thread, and I start backing this out while I'm moving this back. If you want to see this. I turn this and I move this back until it just starts catching. Okay, it just catches. So I know now that the way this is set, it's going to start cutting depending on what I set this on. So now I'm going to take this and I'm going to move it 5 thousandths, 15 thousandths, 25 thousandths. I'm going to take a 25 thousandth movement and cut. So now I'm going to turn this on. This is locked down. So now I'm going to advance into the cut. I always hold on to the chuck. This cut right here, if something catches, it's going to tighten it. But when I cut the male thread, it's going to loosen it. So I don't want to think about that, so I always hang on to it. I don't have to worry about a stop because it's a female thread and it goes into space. So I don't have any gap that I have to pull out on. I cut this all the way until it stops making racket. I don't know if you can see anything, but if you can't see anything, it's his fault. All right, now I stop that, and I look at that thread. Now Chris was cutting it till he had a sharp, he was making a sharp thread, and then he was knocking that off, and I don't want that. I don't want to ever make a sharp thread. So I want this all cut off. I want to stop there. And the reason for that is that little top there doesn't stand up anyways. Why make it? So I don't make it. So I want these threads to be flat on top. So I look at it and I say, well, they're flat on top, but if it was out in my shop, I'd probably quit, but I'm going to make this harder. So I'm going to say, I want them a little deeper. So I'm going to pull it back another, I'll do 7 thousandths just to make it tough. And I'll cut again. It's pretty easy, isn't it? Shut it off. Back it out of there. It's a beautiful thread. The tops are flat. They're not, they're not sharp. They're not breaking off. I know this thread's good, and I know I'm not going to do anything more to this thread, but I still put the block on. And the reason I put the block on is because the next step, I need the block. And if I start trying to put it on here and not putting it on there, the next thing you know, I'm going to forget to put it on. So I always do it. So now I pull this out, and just to make Chris happy, I'll just take a little sandpaper and I just go like this and do this. This thread does not require that. And I get all these free toothbrushes from the dentist. I never use them in my mouth. But I can clean out the thread, so you can do that just to make sure everything's okay. So now this thread is done. Can you see? You see that? That doesn't show up. It's a beautiful thread. There's nothing anywhere on it. So I take this. I'll tell you what. I'll do this here. You can just kind of look at what I'm doing here. Now, I have a digital caliper. If you're going to do threading, get one. When I started doing threading, I was doing it with a mechanical caliper. And I would take the mechanical caliper and I would set it in here. And by the way, Donna, you can set this up either on metric or on English. I was impressed that you kept yours on metric because I convert mine to English, and I shouldn't do that. But it is in English. It's zeroed out. So I'll open this up and I'll see 1.806, 1.805, 1.811, ignore that. 1.810. So I'll make a couple of measurements and just kind of see. So 1.811 seems to be the thing. Now what you can do on these calipers, you just zero this. Zero it. Now this is the female thread. So the male thread has to go bigger than this. And on a 16 threads per inch, I run it out 46 thousandths. So I will open this up 46 thousandths. Lock it down, shut it off. This is going to be the size of the tenon that the male thread has to be. Precisely. No guessing, no screwing around. This is what it's going to be. So I'll put this back in here. And I'll take this out. So if I pass this around, I got to get it back before I finish the thread on the other end. I don't know if I can do, probably shouldn't do that. Huh? So I've got another piece of wood. This is a black walnut. This piece of wood has been drying for, I think, 5 years. I'm not worried about it, whether it's dry or not. But you know what I did to get in preparation for this? I took this piece of wood, which is a big square or rectangular piece. I took it and I turned it round and I turned it to about the diameter that I wanted the closure to be. And why did I do that? Well, I wanted to make sure that if there was anything moving in there, I wanted it to settle down to where I want to be. So always thinking in terms of that, always thinking, I want everything to stay dead on. And now I know the size here, and you can see I got plenty of overhang. So I'm going to start out by just turning this down a little bit. It doesn't need to be that big. Don't need that much overhang. Plus it's not running true either, so. And then like Chris did, I'm gonna flatten out the end. I'm not gonna use a skew though. I'm waiting for that. Okay, so now I've got that flattened out. That doesn't have to be concave, convex. It can be dead flat, doesn't matter. And now I'm going to cut a tenon that's basically going to be the male thread, and I'm going to use a bedan. Can you see that? Yeah, that's good. Just a simple bedan, and I'm going to come in here and I'll just stop here, make sure I about what I got left. Now, how long should I make this? The female thread doesn't matter. You make that 1.5 inches long, doesn't make any difference. This makes all the difference. And why does it make all the difference? Well, let's say you've got a 16 threads per inch on the male, and let's say you make it a 1/2 inch longer than it needs to be. Each time you turn this, you turn it about a 1/4 turn. If you got a 1/2 inch extra, that's how many threads? It's 8 threads. 8. And you're turning it a 1/4 each time. That's 4 times 8. How much is that? 32. Look at we got a math guy. I knew I didn't need to bring my calculator. So I got to turn this frickin' thing 32 times to tighten it up. I don't want to do that. You say, well, maybe you could spin it. Well, maybe, but maybe it isn't going to spin. So when you make the male thread so damn long, you end up with a exaggerated long tightening process and loosening process. Initially, I didn't care because I thought, there are cremains in there. This is going to be a 1 or 2 time job. So you got to screw a little longer to get it open and shut. So what? But then you might want to open it and close it more than twice. So I try to keep my male tenon shorter so I don't have so damn many threads that I got to tighten up. And so I tend to go that way. And actually, in fact, that one box you sent around, Chris, I saw that 1/2 of that Osage orange had like 2 threads. That's enough. 2 threads is enough, especially in Osage orange. And so, so you're sitting there, what you're doing is you're overkilling the damn thing by putting too many threads on it. Okay, a little more. You ever notice how the damn thing, you think, okay, one more cut, one more, and then all of a sudden it's a 1/16 of an inch loose? How did that happen? Okay, actually I'm pretty close. Now, are you paying attention, Chris? See this tool? This is a skew. Can you find me? This is a skew. So those of you that know me probably wonder, what the hell am I doing with this? This is one place where I do use a skew. And I use it for one thing only. And that's this little rim here. I cut down through that. When you cut cross grain, you're going to make a rough cut. So I want a nice smooth cut because I know I'm not going to go in there and be able to sand that. I don't want to ever touch that again. So I'm going to get the best surface possible, and it's going to be a skew, and I want it a little undercut. And by the way, my usage of the skew, you probably can't see that, but this is, I take it to the grinder about every 5 years, and then in between the 5 years, I do a little honing. You can see I've flattened that out. When I get it all flat, then it goes to the grinder again. But I got another 3 years on this. So I'm going to just come in here and just And then I'm going to do a little, a skew is also a regular scraper. Still too tight. You know, some of you might think, well, it's sloped like this, so it's a negative rake scraper, but it's not. It's a skew, and it's a scraper, and it's dull, but it still scrapes well enough for this. A negative rake scraper would have a burr on there, and there's no burr on this. I don't want a burr on it. Let's see. Now the other thing I'm going to do, remember how I cut that little groove into the female thread and then I chamfered it off? I'm going to chamfer the front of this. And it's the same reason. It's the same reasoning for chamfering the other. It lets the thread start, you know, and Chris rounded it off. It lets the thread start cleaner when I do that. If I was home, I would sand this off to finish. And then I would just kind of wow people. I would just do this and that way if somebody gets nosy and looks into the closure, they'll see there's some concentric rings in there. They don't really do anything. But that's usually, I usually do that. All right, so this now is ready to thread. So I got to, again, remember to not loosen it. So I'll take this back over here. Now there's a, see, Rob, I remember to lift this up. So now I've got the male thread to cut. So I got to back up here. Again, this is to me, the most tedious part of the whole damn thing. And now I'm going to cut into a shoulder. Now, Chris, when you're hand chasing, you can't do that. You've got to cut a relief, and the relief's got to be big enough so that you can pull the threader out before you hit the back shoulder. And Chris probably only needs 1/8 of an inch. Some of you old guys probably need 1/4 of an inch, maybe 1/2 an inch to get out of there. So I don't need that. I don't need anything. Donna, I think you cut a relief too, but I don't do it. I don't cut any relief. Don't need to. And the reason I don't need to is because I put that little groove in the female thread. So now we'll move this up into the vicinity. I pull it toward me, lock it down, bring the block up, make sure this is all clean, lock that down, tighten it down. And now I'm going to come up here and I'm going to find so it just touches. It just touches. And then I'm going to go, I got to push in 5, 15 thousandths, 25 thousandths. I usually take 25 on the first cut. Now I hold it because now the rotation of the cutter would actually unscrew this. So I don't want that to happen because that changes everything in a way you don't want. So now we're cutting, this is an end grain piece of black walnut. And I cut, I don't look, it's all feel. Watch Tom, still awake. Hear the sound difference? I can hear it. I know I'm up against the shoulder. Quit. Back up. Now, that thread might be okay. Just to show what I would normally do, I might at home, I might cut it again. But here I can loosen it up, bring it back, and take my female and see if they're compatible. It's snug. No good. So, just bring it back to the block, pull it, lock it, and say, I'm going to push it another, we'll go 8 thousandths. See, and this thread has to, it has to line up. You don't want to be, each time you come back, you don't want to be cutting a little different thread. It's probably not perfect, but it's pretty close. I could feel it, hear it. Go back up. And we'll check it again. Normally what I do is I'll usually just make sure there's not any little burr or anything sticking up. I'll just take this is 120 and clean it out and try this. Now remember, I don't want this squeaking, I want it loose. Didn't you see me? You must have been sleeping when I measured. I did measure this, and then added the 46 thousandths. So I measured precisely where I want it to be. Now it's just a matter of how deep I have to cut the thread in. But I don't come back here with a gouge. This is just strictly cut the thread deep enough so that it's loose. I'll go another 7 or 8. Now what I may have done is I picked a diameter for the tenon that was probably a little bigger. I picked one of the bigger numbers instead of one of the smaller ones. Because usually it's once or twice that I pass and I'm done. So we'll try again. Got to be loose. That's what I want. So if we take this out, so here we go. You see that, how that fits tight down there? You see that? No, nothing drunken, nothing twisted. Nice and tight. Nice and tight. And if you like real bulky finials, then you're done. If you want to make them a little fancier, you got all that wood, you can do that. I frequently now will make a kind of a doorknob thing, especially on the bigger urns. So sometimes I do the doorknob, sometimes I do the finial. Always I cut this one so I could do either. I've got plenty here to make a, a nice Cindy Droz to finial. And the other thing I tend to do is when I start cutting from here, I will repeat this shape. So the bottom part of this will be a miniature of this. And then the top will be like a teardrop or something. So I do that all the time. And if you got 10 pieces laying there, you can pick up a finial and you know which one goes where. So you don't have to fiddle around which one fits. So a couple more things that are good to know. When I first started doing this, I thought, well, I can just chuck this piece up again, put this on here, and turn the finial right on here. No, don't. Don't even think about it. So then I would say, well, what if I got just a little one like this? I could use this to hold the finial. No, don't. Well, even a smaller one, can I hold it with this? No, don't. This thing is hollow. You're gonna get vibration when you're out there cutting and shaping this closure, no matter whether it's a fancy finial or even just a simple knob like that. So, what do? I make a female holder. Okay, so I make these. So now I can take this, I can screw that in there, and I can chuck that up. Now I got a solid block of wood and I can do whatever I want here, including changing the diameter of this piece. I can turn right into this block because it's sacrificial. I don't have to worry about cutting this block. So I can do everything I want to shape this to what I want, and I can do it fast, and I can sand it, and then I can come back and I can put it and fit it back into here. Okay, and I will make that, I don't know if you can see this, but when I fit this, I have a very small flat piece here, but I've actually made this so when it goes in here, there's a little ledge. You don't want it flush, you want it set back. Always set back a little. If you make it totally flush and you get off just a little bit, looks like hell. If you put a little ledge on there, you can't see it. Even if you're off a few thousandths, you can't.